Hey guys, we're going to talk about literal equations, and these are the kind of like the little introduction that I wanted to give you as to what the heck is a literal equation. So what is a literal equation? It's basically generally an equation with more than one variable. So like this one has one, I was about to put it on the 5, the 2, it has 3 variables, and they want you to solve for one of them, as opposed to like solving for like an actual solution. They said, hey, can you just give me like solve this for h? So let's do that. Let's solve this for h. And if you're wondering like why is this thing here and why is this thing here, this right here is the equation or the formula, whatever you want to say, is for the area of a triangle. The area equals 1/2 times the base times the height. And it would be one thing if I said, hey guys, I have this triangle here and its height is, 8, and the entire area, which area covers the whole thing, is like 40 inches squared. That would be one thing, but that's not what we're saying, okay? We are saying, what if I just asked you to rearrange this for the height? So here's what I'm gonna do. The height is being multiplied by b and by 1/2. So I'm going to divide this entire side of the equation in one single step. I'm going to divide by 1/2 b. And I'm going to divide this side by 1/2 b. And if you're like, how is that 1/2? 0.5 is 1/2, okay? In fact, here, if it helps you, I could write it like this. This is how you might be used to seeing the area. Base 1/2 base times height. Okay, so in this situation, maybe you would want to multiply by 2 first, and you get 2 times the area equals base times height. Either way, now we're going to be dividing by b on both sides, and we get that the height of a triangle is equal to twice its area divided by its base. And if you're like, well, wait, that's not what you got over here, because if you were to, when you divide by fractions, remember, so what I got here was the height equals the area over 1/2 base, and just the way that that is written, it actually is. These are the same, so don't worry. Anyway, how about this one? Well, hang on. Let's go jump over here and do a couple of examples, kind of like the one that we just did, because this one will be a little bit more like that one right there. Okay. So this first one is going to be useful when we're trying to graph. So like this might be the standard form. This is a standard form of a linear equation or a linear function. And you might be thinking, well, I know it more as like, I remember the slope-intercept form. Okay, slope-intercept form, if you remember it, yeah, it's y equals mx plus b, but the standard equation is really ax plus by equals c. And isn't that kind of what we have? Ax by equals c. Anyway, so why would you need to solve? Because maybe you'd rather do it like this, because maybe you know how to graph this immediately. Anyway, here's what we're going to do. We're going to solve for y. And I'm going to move everything away from y. So I now have negative 3y equals 12 minus 2x. We could have written it like this, by the way. Negative 2x plus 12. These two are identical in meaning, okay? And then I'm going to divide by negative 3. In fact, I'm going to kind of show you the 2 different ways you could write divide by negative 3. This is one way, this is another, okay? So, and if you're like, wait, what do you mean? There's 2 different ways. This is exactly the same as this. It's just that I kind of broke this term up into its parts, okay? So, long story short, your final answer is going to look like this. Y equals negative 4 plus 2/3 x. Y equals, and then check this one out. Since we kind of wrote it the other direction, it's still going to be 2/3 x, but now it's minus 4. So like I said, these two are equal in meaning. They're just kind of rearranged, all right? They're both perfectly fine. And this one most closely resembles our slope-intercept form, so maybe you prefer this one. You give it 3 stars, and maybe you only give this one 1.5 stars. I don't know how to draw 1.5 stars. Oh, I got an idea. We'll erase half of it. There, got 1.5 stars. All right, that was dumb, but you get the idea. So I asked you to try this one in class. So if you're watching this and have no idea what you're doing, maybe pause it and then try. Here we go. Solving for y, I'm going to subtract 4x. How do you know what you should be subtracting by and whatnot? Basically, it's up to you, okay? You want to get the y by itself, and how we do that is by doing the opposite of PEMDAS. This direction, you are simplifying. And this direction, you are solving by doing the opposite. In fact, if you know this, feel free to kind of skip ahead in the video. We want to deal with the adding and subtracting first, generally speaking, which is why I dealt with that. In fact, here, I'm going to connect these little ideas. This idea is right here. That's what I just said. I dealt with the adding and subtracting. Because next, what I'm going to do right here is divide by -2. And notice that the next thing over here would be dealing with multiplying and dividing. And that is what we did next, right? So, final answer time, y equals 2x minus 8. We're done with that. So now we're to this one, which if you were to just try and like subtract or add, you're gonna get stuck. Why? Because there's an x there and there's an x there. And that would be okay if it was just 3x plus 5x, it would equal 8x. But that's not what we have, right? We've got 3x plus 5xz. So remember what I said, let's skip this one? Well, let's come back to it. This is surface area of a rectangular prism. What's a rectangular prism? Think of a tissue box. Tissue box, shoe box, basically a box is a rectangular prism. What if I said, all right, I don't want to find the surface area of a rectangular prism. I would like to find the width of the rectangular prism. I want you to solve this thing for the width. Okay, I'll do it. So here's what I'm going to do first. I'm going to rewrite it down here. 2 times the length times the width plus 2 times the length times the height plus, you know what, I made a boo-boo. There's supposed to be a 2 here. Because there's 2 sides to every part of this box. So my bad on the boo-boo, 2WH. All right, so if I'm looking for the width, I notice this guy doesn't have a width. So I'm gonna move him away. I'm gonna move him over here. And you might think, oh, wow, you can subtract that whole thing? Yeah, just like you can subtract one term, you can subtract, I mean, that is one term, so you could subtract the whole thing. So now we have surface area minus 2 length height equals 2 length width plus 2 width height. Now, in class, I joked and said, hey, we did hangman, and they very quickly figured out that it was factor, because I guess I'm not very original as the math teacher, whatever. But I like to play hangman, so, whatever. All right, so we're going to factor. Well, wait, what is factor? Let me show you. We want this W. Oh, look, there's 2 of them. So here's what we're going to do. We're going to write that W outside of some parentheses. And what's going to happen is 2L gets kind of moved right there. And 2H gets moved right there. That is factoring. And what we did is we factored out the H. Sorry, the W. How can you do that? Well, in math, if you do something, you have to be able to undo it. And if we were to undo this, it wouldn't be called factoring, it would be called distributing. So check this out. Let me grab that. Can I grab just that part? Nope. Okay, can I try this? I'm gonna copy it like this. I don't know if you can actually see me drawing the copy thing, but you can see the results. So there it is. If I were to distribute, I think you know how this is gonna go. The W multiplies that term, and I would now have 2 length width. And the W multiplies that term, and I would have plus 2 width height. I can hear the question maybe in the back of your mind of, well, what if you had written 2 width length and 2 height width? First of all, that's kind of hard to say, and a thought that you might really be annoyed with. You can do that because of the commutative property. What's 2 times 3 times 4? Well, you might say it's 6 times 4, which is 24. What's 2 times 3 times 4? Well, you might say it's 2 times 12, which is 24. And what's 2 times 3 times 4? Well, you might say that it's 8 times 3, which is 24. Each time I did it differently. The first time I did these two, the second time I did these two, and then last time I did these two. Commutative property works for multiplication. We could switch them around. So that's why all of these are the same. And yes, I didn't write them in different order, but 2, 3, 4 is the same as 3, 4, 2 is the same as 2, 4, 3. Okay. So distributing takes the item and literally it distributes it. It multiplies it. Factoring is the opposite of that. So if you think about it, it's back to PEMDAS over here, and that when we are solving, factoring is basically a method, a version of multiplying and dividing, okay? So way back over here, we found that the answer, well, we didn't find the answer yet. And I know you're just super excited waiting to hear the answer. Well, we factored out the width, yeah? Now what we're gonna do, this is gonna feel a little crazy. We're gonna divide the entire right side by 2L plus 2H. And we're gonna divide this side by 2L plus 2H. And then here, I'm going to, if I can, I'm gonna try and scooch all of this info over. There we go. And now here's what I've got, that the width of a rectangular prism is equal to its surface area minus 2 times its length times height, all divided by 2 times its length plus 2 times its height. Wow. You might be thinking, why in the world is that relevant at all? It really might not be relevant to like anything individually you do, but I'm just telling you, what we did just now is we took this giant equation and we solved it for W, knowing that there's a W there and a W there. These guys right here will be much easier. Let's check them out. So we're solving for X, right? Okay, well, there's an X here, as we said. There's an X here, there's an X here. So here's what I'm gonna do. I'm gonna erase those. And what I'm gonna do is notice that this X is multiplying that 3. That X is multiplying both of those guys. I can basically, I'm gonna put divide in quotation marks, but really what I'm doing is I am factoring out the X, okay? So when I do that, what's left behind from this? X. What's left behind from this? Plus 5z. And then that y is still just hanging out there on the left side. Now, I'm going to divide the entire thing by x plus 5z, divide by x plus 5z, and I now have that x equals, because by the way, that cancels all of that, and I'm left with y over x plus 5z. That would be solving that equation for x. Wahoo! Next, let's solve this for y. And you might think, well, this looks a lot different than the other one. The other one had like a 5y. This one just has 1y. So what I'm going to do is I'm going to factor out a y. So what is left behind when I factor a y out of this? 2x. And what's left when I factor out a y from this? 1. Remember, it's dividing and factoring. That's essentially what I'm doing. Dividing, by the way, I said dividing, and I did air quotes. There are my actual quotes, okay? So when you divide y by y, you get 1. And then that 8 is still just there. We haven't done anything to the 8 yet. Now we're going to divide the entire thing by 2x plus 1, and we get y equals 8 over 2x plus 1. And then just for fun, some of y'all might have been like, well, wait, up here, you did like this thing where you wrote it like that and then you split it up. Or here you split it up already. What about down here? Well, if you wanted to, yeah, we could split this up. Here's what it would look like. 8, no, actually, I'm sorry, we can't. I was thinking, in my head, I was thinking it looked like this, and I was about to split it up. If it had looked like this, it would have been 1/4 x plus 1/8, or x over 4 plus 1 over 8, but we didn't have that. So this is the actual answer. Cool? A truck driver drives an average of 60 miles per hour while delivering freight to a customer. I'm just going to tell you right now that some equations, they're going to kind of think that maybe you know them. For example, distance equals rate times time. I think I remember in class like telling you there's others that they might think you should know. I don't think they'll show up as much. Force equals mass times acceleration. Dirt is one of them. This is dirt. I like to call it dirt. Anyway, they average 60 miles per hour. Well, that is their rate. So we could already kind of write this, just by the way. So they average that much, delivering to a customer. And on the return trip, they average 50 miles per hour. Okay, well, that's a different dirt. That is 50 miles per hour, right? The total driving time is 6 hours and 36 minutes. How long does each trip take? So what we're going to do is I'm going to actually move all this stuff again. Magic, it's moved. What we're going to do is we're going to go, hey, you know what? The distance here and the distance here, they're the exact same thing, okay? So what I'm going to do is I'm going to solve both of these for time, okay? So that means I'm going to divide this by 60, divide by 60. I'm going to divide this by 50, divide this by 50. So what I have over here on the left is time equals distance over 60. And over here I have time equals distance over 50, right? Okay, so the idea is this is our to trip. And if we add the coming back from the trip, that total time is going to be 6 hours and 36 minutes, okay? So this is where, like, life kind of gets a little complicated because what we did here is this is 60 miles per hour, and so we can't use minutes. So here's what we're going to do. First of all, I kind of went a little fast and just assuming that you were cool with this. It makes sense that how long it took you to get to somewhere plus the time it takes you to get back from there equals the total trip time. In fact, I should even go back and say, listen, whenever you are given a total in a math problem, you should feel so happy. This guy doesn't look very happy, but you should feel so happy because you equal a total right away. You can write equals that thing like every time, and it's so great and wonderful. But now back to the idea that we have miles per hour, and sort of hours here. What we're going to do is let's convert let's convert this to hours. So we're going to just convert it to hours. That is 6 and 36 sixtieths. Why is that? Because this is hours, and this is the number of partial hours that we drove. So now I'm also going to substitute in this right here. So we're going to have d over 60 miles per hour plus d over 50 miles per hour, and that is equal to 6.6 hours. And in fact, wait, what? This, if you were to convert it to a decimal, 36 over 60 is really 3/5. How is that? Well, because if you divide both of these by 12, you get 3/5, and 3/5 is 0.6, so thus 6.6. Now, how you solve this is up to you, because technically it's just one variable, and yeah, we have some ugly looking fractions. So here's what I'm going to do. I'm going to multiply both sides, I'm going to multiply both sides by 300. Why am I doing that? You might see it in a second. If I were to get a common denominator, 300 would probably work, right? But if I just go ahead and multiply by 300, then I just have no fractions. So if I multiply this by 300, I'm going to show my step here, even though I hate to do that, just out of pure laziness. This is what I would get, and here's what that will end up being. This is now 5d plus 6d. 300 divided by 60 is 5. 300 divided by 50 is 6, okay? And then that's going to equal, what's 6.6 times 300 is 1980. All right, add these together to get 11d. Divide both sides by 11, and you get that d equals 180. Now let's pause here for a second. D equals 180. Isn't that the d from distance equals rate times time? Weren't we trying to figure out things in terms of time? You're absolutely right. But if we have the distance, and we have the rate, we can figure out the time. And that's exactly what happened up here. We can now take the fact that our trip was 180 miles, and we plug it in right here. So the to trip, let me do a different color here so it really stands out. The to trip is really time equals 180 divided by 60. So our to trip took 3 hours. And then our from trip is, our time is 180 divided by 5. And that is 3.6 hours. So what was the question? How long does each trip take? Getting there took 3 hours. Getting back took 3.6. And it should work out that when you add 3 and 3.6 that you get 6.6. So that might have seemed like, holy cow, there's a lot to that. But I think it also kind of makes sense once you think about all of it. So that's our notes for literal equations for now. Let me know what questions you have. See ya.